Hello everyone. Let's talk about our next topic, that is electric lines of force. Electric lines of force are also known as electric field lines, and they are defined as imaginary smooth curves drawn in an electric field along with which a free positive charge moves in that field. Means if a positive charge is set to free in an electric field, then the path along which that positive charge will move will represent electric lines of force. These lines of force are in the form of smooth curves. They are in form of smooth curves. These electric field lines also represent the direction of that electric field at those particular points. Now we have some shapes of electric field lines or electric lines of forces as per the given charges. So first of all, for positive charge, suppose we have an isolated positive charge. So the shape of electric field lines due to that positive charge will be like this. All the field lines are looking to coming out from the positive charge like this as shown in the diagram. Similarly, for a negative charge, the shape of lines are again same, but the basic difference between these two diagrams is the direction of arrows on the lines. All these lines are looking to terminate at the negative charge. Suppose we have a pair of one positive and one negative charge, then the shape of electric field lines will be like that. And for a pair of two positive charges, these electric field lines will be like that. Clear? Next, we have a line of charge. Suppose positive charge is uniformly distributed over a straight line, then the electric lines of forces for this line of charge will be like this. These electric field lines are radially outwards from this line of charge. So let's move out to the next topic. Next is properties of electric lines of force. First property is these lines originate on positive charges and terminate at negative charges. So from the diagram we can see all the electric field lines are originating at the positive charge and terminating at negative charge. So this is the first property. Let's move towards the second property. Tangent drawn at any point on the line of force gives the direction of that electric field. Means wherever you want to find out the direction of electric field, just draw a tangent at that point on the electric field line. Next, no two electric field lines can intersect each other. For a particular electric field, no two electric field lines can intersect each other. Next is these lines of force do not pass through a conductor. Means suppose we keep a conductor in the path of electric field lines, then the electric field lines will be invisible inside the conductor. Next, the place where field lines are close to each other, the intensity of electric field will be strong. Means the places where electric field lines are closer to each other will represent strong electric field, and the places where electric field lines are far away from each other represents weak electric field. Means suppose near to this charge here, electric lines of forces are very near to each other. Means at all these points the intensity of electric field will be strong, and at these points where field lines are separated from each other, the intensity of electric field will be weak. So now moving towards the next point, the next property is parallel and equidistant electric field lines represent uniform electric field, means the place where electric field lines are parallel and equidistant from each other, then the electric field will be uniform in nature. Next topic is electric dipole and electric dipole moment. So you can see in the diagram there are two charges. First is minus q and second is plus q, and they are kept as such that they are separated by a small distance 2l from each other. So the definition: an electric dipole is a pair of equal in magnitude and opposite in nature, means one is negative and other one is positive charges placed at a short distance from each other. That pair is called electric dipole. And the product of one charge and distance between charges is called magnitude of electric dipole moment. Electric dipole moment is represented by P, and it is equal to P is equal to Q into 2L. Q is the magnitude of any one of the charge multiplied with distance between charges is called electric dipole moment. Its unit will be coulomb meter. The direction of electric dipole moment is from negative to positive, means electric dipole moment is a vector quantity and its direction is always from negative to positive. That's all for this video.